Welcome back to Math 109 Plane Trigonometry. In this video, we're going to take a look at the derivation of the law of sines, which we'll later be able to use to solve triangles when we're given two angles. So we're going to start by drawing a triangle, A, B, C, and as was standard practice earlier, we're going to define the opposite side lengths to be lowercase a, b, and c. So I'm going to start the derivation by drawing a perpendicular line from angle B. Now, you'll recall from high school geometry, that's a height of the triangle, so we're going to call that length h. So now, I'm going to consider angle A. We know that the sine of A is the opposite side in a right triangle, so in this case that's h, over the hypotenuse of that right triangle, which is c, which implies that c times the sine of A is equal to h. Likewise, the sine of C is equal to h over A, thus implying A times the sine of C is equal to h. Now, since both C sine A and A sine C are equal to h, they have to be equal to each other. So we get A sine C is equal to C sine A. Now this is a form of the law of sines, but this is not normally how you see it written. I'm going to go ahead and divide both sides of this by C. So we're going to get A sine C over C is equal to sine of A. And now I'll go ahead and divide both sides by A. So that'll give me sine of C over C is equal to sine of A over A. But now I will point out that I just as easily could have done this whole derivation drawing that altitude from either angle A or angle C, which would have given me the same result, just switching A's, B's, and C's around. So the most common form of the law of sines that you'll see is sine of A over A equals sine of B over B equals sine of C over C. And when we have three things equal to each other, that also means any two of them are equal to each other, which will be useful when we solve problems. So that'll do it for this video. In the next video, we're going to take a look at an example of how to solve a triangle when we're given two angles and a side.